Hi twin, welcome to my review and ratio and reads test. I'm so sorry. If you can hear some like background noise, I do have the the F1 like free practice theory on. I do have that pulled up, so sorry if you can hear that. Just ignore it and focus on my beautiful teaching skills. Okay. So this is the ratio test, and basically, you can use this test like whenever you want. You know, like other tests has like specific conditions you need to meet. Like some tests it has to be positive, it has to be decreasing, or for the alternating test, it has to be negative. This test does not give a fuck. You can use it whenever. It just when you use a test, sometimes it just like won't tell you anything, and like it just won't be the correct test to use, and it will tell you to use a different test. Like for example, after you do the test, right? And because we're finding the ratio, right? And in this case, L here is whatever like the I guess the ratio is after we find the limit, right? So if L is less than 1, then that means the series converges, absolutely. And if L is greater than 1, then that means the series diverges. And if it's equal to 1, that means use a different test. So if you use a test and yeah, like you can use a test for whenever, but here, I'll write the thing. If it's L equals 1, that usually means that the ratio isn't growing fast enough, or the change isn't fast enough for us to tell using this test. So like if we look at I guess the order of exponential growth, so I'll write it out. You should probably know this twin, so memorize this. So this goes less than and then and factorial. For the ratio test, you usually use it when we have factorials. Like if the question like usually will not tell you to use the ratio test. You just have to like kind of decide which test you want to use. And like in this example, if it has the factorial, that's like how you know you should use the ratio test. But this is the order of exponentials. I don't know if I need that. These are ends, by the way. So this is the order. Like this is faster than that, or whatever. And so draw like a line, like a mental line here. Anywhere like on the left side of this means that it's not growing fast enough. It's too slow, so the L is going to equal to 1. So basically, if your series, the dominant terms are these, that means don't use the ratio test, use something else. But if it's on this side, you can use the ratio test. So like example for this side, if you have like any like polynomial or any like if it's like this, then you can use, you see like this is too slow. So you don't use the, like if you do use the ratio test, this is the L is going to equal 1. So that just means use a different test, and we know you can use a generalized p-test for that. Or if you have like any polynomial, sorry I forgot this, series, so if it's like any like of this stuff, my Siri just went off. I'm sorry Siri, I did not say your name. Okay, like I don't know if you can see that one. Wow, okay. Just like, if it's like any like n4 or n3, you know, don't use the ratio test, is basically what I'm saying. Okay? Um, and then I'll do an example. Okay. So using ratio test to determine if this series converges or diverges. Okay, so so we want to rewrite it. And then, okay. And then the setup for this test is right here. So right here. So a sub n plus 1 divided by a sub n and the absolute value of that. Okay. So I'll rewrite it right here so you can see it. And then since this is the first one, I'll go through each step. I'll write everything out. Okay. So so like what does this mean? Okay. This is a sub n, right? Or I guess this is a sub n, right? So what does the n plus 1 mean? That just means like whenever you have the n, you want to just add plus 1. So in this case, a sub n plus 1 is going to equal, so we have on the top we have 2 and then n plus 1, right? Divided by, we have the n here, so n plus 1 factorial. It's going to be like that, okay? So, ooh, I probably should have written it there, but that's okay. So, and then after you do that, you divide that by the a sub n. So in this case, it's going to look like this. So we have, ooh, that's an 8, not infinity. Okay. So we have the a sub n plus 1, this thing over here, right? So we're going to write that out. 2 plus 1 divided by n plus 1, which is factorial, right? And then all divided by a sub n, right? Usually, like when you like do more of these and get used to it, you can just like already do the keep change flip. But since it's the first one, I'll write it all out. So you have this, and then we do keep change flip. So keep, I'll change the color, keep change, and then we flip this, so we get n factorial to n. Yeah, that makes sense. So now we're just looking at this part. Okay, and then now it's like the cancellation phase. Okay, I'll rewrite it here. I'll rewrite it. So usually when you like want to rewrite it, you like write the similar terms over each other so you can simplify easier. So in this case, like the 2n plus 1, it's gonna be like similar to this one, right? So when we do it, it's just like easier to look at, I guess. And then n factorial here, and then n plus 1. Right. Okay. So this is our equation now. Now looking at it, there's no like immediate cancellation, right? So that's when the like factorial stuff comes out, because that's what like factorials are, right? It's like successive integers. It's like everything after. So I'll write it in red. Sure. So you see in this case, like these are already like simplified. Here, these are already like simplified. So like we can't expand those, but we can expand these two, right? So I'll do this one first right here. So 2 to the n plus 1, you can also write this as 2n plus 2, 1, right? And this is just equal. Wait, I just lied to you. It's multiplied, I'm sorry. So when you expand it, it's multiplied. So it's 2 to the n power times 2 to the first power, you see from here. And then, so you just get 2n times 2, so we can rewrite that as that, right? And now we can see that this one cancels out with this one, right? And then rewrite this, the bottom one. When it comes to factorials, it's like the next one, right? So the next, so like in this case, when you write it all out, it's n plus 1, right? And then what's the one after this? Just n, right? So then, and we add the factorial at the end, and then you can see that now this cancels out with this. So now we have, so now like the red replaces the blue. Does that make sense? So if we rewrite this for our final, like after it's all simplified, we have, you see, right here. Shoot, I should use a different color. Oopsies. I'll just go back to black. So this is gonna equal. Oh my god, that's straight up an 8. Okay, so we see this replaced this, this right here, right? So, and this would cancel out this, so we only have 2 left on the top, okay? And then on this bottom one, this replaced this, right? And then looking at this cancels out with that, so now we just have n plus 1 on the bottom. And then we take the limit of that, so in approaching infinity, 2 over infinity, any constant over infinity is 0. So, so that's less than 1, right? And then we look at the thing, when L is less than 1, that means the series converges absolutely. So, for this one, we can just write, oh, I have no space. We write since L is less than 1, you have to write this as your, like, part of the explanation. Even if you like write it down, it's just like better to write it just in case. Our series converge by ratio test. Right, and then that's your answer. Yep. So you see, not too bad. Ratio test, not the worst. Okay, I'll give you a second to look at it. Okay, next one. Okay, so use the ratio test to determine if this series converges or diverges. So you can see we have, in this question we have 2 factorials and then an exponent right there. You see? So I'll write it out. Equals limit. And then I'll write this so you can see. Oh yeah, the absolute value. It can just disappear if you know, like, it will never be negative. Like, since this equation right here, like the first one, this series is already positive. Like, it's always going to be positive, so we can just ignore the absolute value bars. And that's the same with this test, or this question right here. It's always going to be positive, but we can just write it here just to remember. Okay, so here I can write here. I'll write it out for you to see. So a sub n is just this, right? We can do it part by part. So let's focus on the top first, okay? Green. Green. So a sub n is going to be 2n, right? Right, and then so that means when it's this one right here, a n plus 1, that's going to equal, so now the 2 is outside of the n, right? So it's the 2 will be on the outside of the n, so then we do n plus 1 inside of the parentheses, and then all of this is going to be multiplied by the factorial, right? You see? So that's like important to see, because now when we expand it further, it's going to be 2n plus 2 factorial, okay? Don't make the mistake, it's not 2n just plus 1. Don't just add the plus 1, right? It's like you're replacing n with n plus 1, okay? So just remember that, okay? And then if we want to look at the bottom, thankful this, oopsies, the bottom's easier. I must have the gay flag. Okay, I'm sorry. I didn't mean to do that. Oopsies. We see this one's easier. N plus 1 equals, and then you just replace n with n plus 1. So in this case, it'd be like, usually when it's exponent, it's easier to look at if you just write it out, like that, right? So now, when we have this one, and it's like that, well, yeah, because it's like, it would be like that, and then like that, right? It's easier to look at if it's just like this. Oopsies. Okay, so remember that. I don't know if I'm gonna have enough space for this, man. Okay, okay, and then so using the use of n plus 1 that we found out, we can plug it back in, right? Plug into this. Ooh. So now we have limit. Okay, and remember it's these equations over a sub n, okay? And I'm just gonna skip the step and just go straight into keep change flip, okay? So just to save space, right? So you have the first one, so we have 2n plus 2 here, right? And then we do the bottom one right here, n plus 1, and then n plus 1 again. Now we do keep change flip with just the a sub n. So in this case, this top one would go to the bottom, and the bottom would go on the top. So rewrite it. It's gonna look like this, and then this is gonna look like this. And then it's just easier to write it out. So I'm gonna write it out. Yep. You see? You know, like now it's time to simplify. But you know, first like there's like nothing we can directly simplify, right? We need to break down the factorials. So we can see that we can break down here. We can break down this one, and we can break down this one. Okay, so I'll do that. Remember for the factorials, you want to do the next one. So if we want to expand the factorials, because it's remember all the successive integers before the thing, if we expand it, it's going to do 2n plus 2, right? Is this one, and then the next one down would be 2n plus 1, right? But that's still not what we want, right? So we have to keep going, and then next one is just 2n, yeah, factorial. And then that's when we know when to stop. We can stop once we like simplify the bottom, and then we just stop there, okay? And then for this bottom one, like what's one of these, right? N plus 1. Well, if you go down, the next one is just n, right? So then both of these can just be, oh wait, sorry, I just made a mistake. You got to keep the first one. So n plus 1, and then the next one down is just n, and then so for both of these, you just got to write it again. Okay, so then cancel everything out, right? This one cancels with this, and this cancels with this, and this cancels with this. So now we write down the leftover, which in this case, it's all of this, right? So we have 2n plus 2, 2n plus 1 on the top, and then on the bottom, we have n plus 1. And then since there's 2 of them, we can just do the next one right there. Right, and then now we just, now that because this whole thing is like getting rid of the factorials, right? So after we have that, we can just try to use like different tests to see like what the, like if it converges or diverges. So in this case, we're gonna be using like the p-test and look at the dominant term. So in this case, the top one, the dominant term, you see 2n times 2n, that's going to be 4 in squared, and then the bottom is just into the second power, right? And then this cancels out, so then our L is going to equal to 4. And then 4, ooh, that's a long 4. 4 is greater than 1. We scroll back up. When L is greater than 1, that means it diverges. So this diverges. And then you can write the series diverge because L is greater than 1 by the ratio test. Yep, and then that's our answer. Boom! Easy twin. Am I right, twin? Okay. Little water break twin. Okay. Okay, look at this one. What the fuck is this? Okay, so use the ratio test to determine if this series converges or it diverges, right? Okay. So we can see there's like no factorials, and then we go back to our little exponential chart thing, right? We can see that this is here, right? Is this one right here? So we know that L is equal to 1, but I'll work it out, because if they say like specifically to use the ratio test to basically show your work why L equals to 1, so that's what we're gonna do, right? So we write it out, right, so n plus 1, right? I'm not gonna write it out, like you can kind of see, right? So that's the top, and then the bottom would be, right? And then that's ace of n plus 1, and then I'm going to put in just ace of n, and then keep change flips, and then would go down there, and then n squared plus 1 would just go right here, okay? So then there's like two ways you can do this. You can like just like look at the dominant terms like as a whole, like if you FOIL everything out, or is that what that's called? I think so. So in this case, the dominant term for this would be n with this, like this times, yeah, this times that, that's n to the third, n cubed, and then this times that is now, oopsies, I should use the same color, is n to the third. So now we know that this is equal to 1. You can also like just look at it in pairs. It's just like whatever is easier for you. Like if we look at this pair first, wow, that's beautiful. Well, n cancels out, so this is 1, so that equals to 1. And then in this case, if we look at this half, right, we've got n squared over n plus 1 squared. So this n squared over n squared, this is equal to 1. So it would still equal to 1. So it's just like just different ways to simplify it, basically. And since it's saying use the ratio test, you just say the ratio test is inconclusive, right? Because when you use the ratio test, and it's equal to 1, when L is equal to 1, it does not tell you if it converges or diverges. So, like, using the other test, right? Like, if we use limit comparison test and we compare this to n over squared, and then which is n over just 1 over n, use the p-test, p equals 1, which is, which using the p-test, that means that p equals 1, that diverge, right? So we know it diverges, but in the answer, unless it like tells you otherwise to use like a different test, you cannot write like if it converges, diverges. You just have to write it is conclusive right here. Yeah, so keep that in mind when okay, next one. Ooh, what the hell? Okay, use a ratio test. Okay, blah 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 blah. This I'm pretty sure is called a running product. Here, I'll write it out. Okay, Twin, I will be honest with you, my knowledge is a little bit limited here, but I'm pretty sure, since you see how like normal factorials, it goes like the next one over, so like in these examples, it goes the next one over when we look for it. This one skips, so this is not important, but like this is like some kind of like double factorial. So, but that's just like don't worry about that right now, Twin. Okay, she can't hurt you. Okay, but basically, when we're taking the a sub n, right? Because we're looking for this one over a sub n, right? So now we gotta look for. Sometimes you could just like write it out like below it without like separately, but like in this case, it would be like helpful to write it on the side to make sure you don't mess it up because it is so long. Right, so I'll write it down. There's like no space here. I'll write it right here. I'll write it in blue. Oopsies, that's not blue. Okay, so if we do the first one first, all right. Absolute value, right? Let me erase this. We're taking the absolute value, you know, when we do it, and this isn't an alternating series, right? This part right here, this is just changing the sign, right? So when we take the absolute value of that, that's just also going to equal to 1. So we could just ignore that part when we do the like the a sub n stuff. So in this case, we're just worried about this when we do the a sub n plus 1, okay? Just remember that, okay? So in this case, you just do n plus 1 factorial, easy, right? And then for the bottom, a sub n, so we gotta write it all out. So 1 times 3 times 5, blah blah blah. 2n. See, remember 2 is on the outside of n, so it's 2, and then n plus 1, and then plus 1, right? So then you do it all out. So this is also 2n plus 3, okay? When you take the a sub n, okay? So if we rewrite it over here, we've got the limit. So I'm going to just go straight to keep change flip, okay? So don't get confused. We have the top one, so the top one is just n plus 1 factorial, right? And then the bottom is this one right here, right? So we have 1 times 3 times 5 times whatever between, and then 2n plus 3. Yes. Oh, I just think this doesn't look right now because I just skipped the thing. Oopsies. Okay, so sorry, I made a mistake right here looking for the a sub n. I just completely forgot to write this. Right? Because you gotta write like it's factorial, right? So you have to write what it is and then the next one. So I'm sorry. I'm sorry to if I confuse you or if I'm confusing you right now. Okay, I'll just erase this. Okay, so ignore everything I said for this one. Okay, 1 times 2 times 3, blah, blah, blah. Okay, now we gotta write what it was. So 2n plus 1, and then we add the n plus 1 here, plus 1 on the outside, and then we could also rewrite this one if we simplify this to 2n plus 3. I'm so sorry, Twin. Okay. Okay, does that make sense? So now you can just ignore this, and then this would be like the whole thing here is alright. It's n plus 1 for the denominator. Okay, it's a little far. Okay. Okay, so when we write it on the bottom here, so sorry, Twin. We write how it was, and then we add n plus. Wow. Okay, perfect. Okay, and then keep change flip. So now we do it when it was normal as a sub n. So times 5. And then, yeah, because it's important not to forget it because it will cancel out. So if you do forget it, and now you have an extra thing on the denominator, and now you're thinking this might be wrong. You're gonna get points off it. I'm so sorry. Okay. So then we do n factorial here. Okay. You know, we gotta expand this again. So n plus 1, and then just n factorial, and then this just cancels out neatly. So that's very nice. So this cancels out right here, and then all this cancels out with this. So now then, when we rewrite it, we have n plus 1 over 2n plus 3. And then, you know, we're just looking at the dominant terms right here, right? So that's going to be, we're just looking at n over 2n, and then, you know, that cancels out, so it's just 1/2, and 1/2 is less than 1, and then we know using the thing that when L is less than 1, then that means it converges. So now we write it out. The series converge because L less than 1 by the ratio test. Okay, and here I'll let you look at the whole thing. So sorry if this confused you, twin. Okay. Okay, so useful limits. This is just like stuff you like should memorize. Because okay, I don't know if you remember. But this is just saying like when you use the hospital rule, remember that for this stuff. When you use like the hospital stuff for this, it's gonna equal this. Use the hospital rule for this, it's gonna equal this. So you can work it out, but it's just like easier to remember it. Okay, to memorize it. So this first one is because remember. Okay, so if the thing looks like this, okay, and it's either going to be written as 1 plus 1 over n, and this is equal to e, okay? Usually it's written like this, n plus a over n, okay, and a is usually 1 or any consonant, and then depending on whatever a is whatever the exponent is. So in this case, it's just like that, right? But if this was a 2, then over here, a would equal to 2, okay? So this is just like some things you should remember to just like save time. And then like likewise, if it's the like reciprocal of that, then it's just obvious. So if it looks like this instead, that's an infinity sign. Trust. So it's like if it's like this, then it's gonna be 1 over e. Okay, yeah. So just remember that. And then this bottom one, number 2, is saying that when you take a limit of any like n square root or any whatever root of a polynomial is going to equal to 1, and also that the limit of any consonant is also equal to 1. Okay, so just remember that. Yeah, give me a second to look at that. I'm definitely not drinking water right now. Okay, so I'll do the next example. So this one. Disgusting, right? We got n in exponents and then more factorial stuff. So we gotta write it out. Okay, so writing it out. Do you want me to write it? Okay, I was gonna ask if you wanted me to write it on the side, but you can't answer right now. Sorry, twin. So I think this one's like, cause like I'll write it up here. So like n plus. Remember, it's this thing again, right? So we saw that before. Oh, right, this one. There's a negative sign, right? And when you do the because it's absolute value, right? You can also rewrite this as negative 1n times 2n, right? And then, because if you split it up like this, then you could just ignore this first part, because that's going to be the alternating sign. So you could just ignore that, because that would just equal to 1 right here. So now, so instead of like this, instead of negative 2, it's just like 2n 2n factorial on the numerator, okay? So here, if we do the thing, I'm going to erase this because I need space, I think. So if we want to do the thing, right, 2, and then it's going to be n plus 1, right? But we know that's also 2n plus 2. I just lied to you. 2 times 2. Like that. Okay. Next one, the 2n factorial. It's just like this, right? Or, yeah, I'll write it all out for the first one. It's after. Okay, I'm sorry, twin. I don't mean to confuse you. Okay, so I'm just gonna write it as it is, right? Okay. Wow, I'm just fumbling. So this is 2 plus 1. Okay, and then the next one, 2n plus 1. And this is factorial, right? And then do the bottom. So we got n to the power of n. So what would that be? Think about it. Okay. Instead of n plus 1, what would it be? Okay, I'm gonna give you 3, 2, 1. Okay. I want to guess he solved it. So n plus 1 to the power of n plus 1. Congrats if you got that, twin. I hope you did, twin. There you go. Okay. So now we just, and now we put in the normal exponential equation. So keep change flip, and it's going to go over here, and then 2n times 2n factorial, which is just going to go down here. Okay. Now we can rewrite this, right? Because we know that this is also going to be equal to 2n times 2, 1, right? Which is just, right? And then, which is just 2, right? And then this one expands further to 2n plus 2 factorial, right? And then this further expanded too. So we keep the first one, 2n plus 1, and which is not that yet. So we have to keep going. And we get 2n factorial. That's very tight. Okay. So then I guess we can expand the bottom too. No, I'll keep that to later. Or I guess we can expand it to, because when you have a plus sign in the exponent, we could split it up, right? So it's easier to work with. So in this case, it's going to be n plus 1 to the n power multiplied by n plus 1 to the first power, okay? Alright, so we can split that up, and I'll work with that in a little bit, okay? But we can simplify these, right? So 2n squared, I mean, just 2 to the n power simplifies with that, and then our 2n factorial over here simplifies with the 2n factorial over there, giving us with this, right? So now we can rewrite it down here. Jeez, that's not an arrow. Okay, so now we got 2n plus 2 times 2n plus 1. And don't forget the 2 right there. Alright, I don't know if you see this one right here, because this split up to the 2, and then this split up to this, right? So just don't forget that. So this is our new numerator. I'm sorry if I didn't explain that clearly. And now we can split this up, right? So now we could bring, because we're trying to simplify the here, right? The n. Basically, what I'm saying is that this one has to an n power, and this has to an n power. So if we want to rewrite it to simplify it further, we can put this one over here, this one right here, leaving the n to the n power over n plus 1 to the n power. So it's easier to look at, right? And we can rewrite this one, right? So if we want to, here, because you're looking at this, okay? We're looking at the left side right here, okay? Looking at this, right? If we want to simplify further, if we want to get rid of the denominator, like, can we? And the answer is yes, right? Because this one right here, or let me use a highlighter. This right here, it can be rewritten as 2 n plus 1, right? And then, oh, we got an n plus 1 right there. So that means that these two cancel right here. So now we can rewrite the numerator as, so we got 2 times 2 now, so that's 4, and then the remaining, okay, so that's this side right here, times this. And like looking at this, can you rewrite it? We can, right? Because they both have n to the n power, so n over n plus 1. Okay, now does this look familiar? Twin, does it look like we do something with this? If you said no, then you're wrong. But remember this. Oh shit, we just went over this for some reason. Okay, it looks like this one right here, doesn't it? So now we know that this, or sorry, it looks like this one right here. So we know that this is going to equal to 1 over e, whatever the exponent is, right? So now we can rewrite this as 1 over e, exponent's 1, so it's just 1 over e, right? And then if we look at if we simplify it further, right, from this times that, which is 1 over e, so just like that, and then take out consonants, right? So so we take out the consonants, which in this case would be 4 over e, constants, not consonants, those are letters, sorry. And then 2n plus 1 will be what we're looking at, and then 2n plus 1 as it approaches infinity, which would be infinity, right? And that's much bigger than 1. So then using the ratio test, when L is greater than 1, it's going to be divergent. So here we write, I'll write it in blue so you can see it. The series diverges because L is greater than 1 by the ratio test. Yep. Okay, well that makes sense to one. Here. Alright. Now we're going to do the root test, okay? Okay, let's see, what is this? Okay, root test is when we're looking at powers of n. So like in this example, you see we have a power of n right there, so it's probably best to use. Like, if it looks like, I'll write some examples. If the series looks like this, ln of n, you can use it, or if it looks like 1 over n factorial, oopsies, and then the bottom is to the n power, right? Or if it looks like, if it looks like, you say if it looks like this into the n power, but like to the 4th power, you can also use it like this, right? Because you can also rewrite this series. You just switch the exponents, right? So you switch the 4 and the n like that, and then you can use the root test. So the root test, this is the new thing that we're going to do. So it's different from the ratio test, so you should remember that. And this test is saying that if L is less than 1, then it converges absolutely. If it's greater than 1, then the series diverges, and if it's L is equal to 1, it uses a different test. So it's the same rules as ratio test, just like a different thing, right? So we do the first one. Okay, so we can rewrite it. And I'll rewrite this so you can see it. So we get the limit. Wow, that's a great handwriting. So it's absolute value of a and n, okay, to 1 over n. Okay, that's what we're subbing again, right? So we look at this. Oh wow. In this case, like again, our a sub n is already positive, so we can just ignore the absolute value thing. So we rewrite it, right? N plus 1, and then all of this to 1 over n power. Okay, and then so how do we do this? Okay, well, it's easier to like spread it out, like, or that's not the right word, like rewrite it so it applies to both the bottom and top, to the bottom, top, to the numerator and the denominator. I'm sorry, so I'm trying to say twin. So if it looks like this, to n power. Yeah, so if we separate it, it would be easier to look at. Okay, so we have this, right? Well, obviously, we can see in the numerator, this and this just cancels out, right? And then this bottom part, it's gonna be rewritten as here, I wrote it in blue. Like if you, right? And remember, from right here, any polynomial to the n power is gonna equal to 1. Okay, so this one equal to 1. So now our new thing is, so now basically our L is equal to, sorry, our limit is equal to n. This is equal to n. So top is equal to n, and and the bottom is equal to 1. So then it's just like that, right? And then you take that approaching infinity, which is just infinity. Okay, that's greater than 1. And so we look at the thing when L is greater than 1. That means the series diverges. So we write the series diverge because L greater than 1 by the root test. Yeah. Sorry, twin, if I was a little bit confusing. I kind of forgot what I was looking at. Okay, so I think it's the last example. Okay, so you're looking at this and you're like, what the hell, right? But it's not a bad one, okay? Even though it's, so we have 2,312 to the nth power to the 2nd power, okay? So you're looking at this and like, what the fuck, right? But we rewrite it out, okay? So we got limit, just don't panic, twin. That's like the thing. Just don't panic. And then, but if we like don't know what to do, and like everything you try isn't working, then maybe panic. JK twin. So I'm rewriting it like this. So we got 1 over n power on the outside, and then on the bottom we got n power to the 2nd power, and then 1 over n. Okay, so here, I'll write it up here, but this is also written as 2312 n times n, right? Ooh, that's a 2, right? Right. So, and then the bottom is also can be rewritten as n times n, right? So that means when we take it to the n power, it's gonna get rid of one of these n's, right? And then when we take it, here, I'll write it right here. That this cancels out one of these, right? This cancels out one of these. So now all we have left is 2312 the n power, and then down here is just into n power, right? So we rewrite that down here. See, not that bad, one. And you can write it as like 2, 3, 1, 2, and like this, or doesn't really matter. Doesn't really matter. Ooh, that's, what am I doing, bro? That's supposed to be an n. Because if you look at it like this, you take the limit, so as n is approaching infinity, well, any constant over infinity is just 0, so 0 to n, that's just 0, right? Which is less than 1. And if you do it this way, let me see. Well, the things, well, yeah, right? Because if you look at it like this, 2,312 to the n power is gonna like, what's that called? Like grow slower than n to the n power, right? As we have remember the exponent chart. So n to the n power is going to be faster than the constant to the n power, right? So this is just saying that since the bottom is growing faster than that, it's going to be like, it's going to be 0 too, right? So it's just like different ways to look at it. And this is also, oopsies, less than 1. So it's whatever, just different ways to look at it. So then you just write this series, converge. Ooh, that's beautiful. The series converge because L less than 1 by the root test. And yep, I think that's it, twin. So that's the root test. That's the ratio test. Not that bad. You got this, twin. You're gonna ace that test, twin.